let's continue on here to letter B. So the first one we divided the -2 over, and we had to find when sine of x equals -1/2. Here we'll divide over the negative, kind of like a -1, and we'll get tan of x equals -1, I guess. Tan of x is equal to -1. This is also the same sort of stuff that we've been doing before, and we need to find when does tan of x equal -1. So what angle can we reference for this? So we'll take a look here. And tan is in the greens, so tan is sine over cos, and it's 1 right here. So at pi over 4. So we can reference pi over 4, wherever this is. There we go. Pi over 4. Now we need to figure out, now that we know that, where is tan positive? Nope, where is tan -1? So when is tan negative? So tan is positive down here, and it's positive here, meaning we're negative, and we're negative. Then I know this gap is pi over 4. Pi over 4. Now this actually isn't drawn very well. Pi over 4 is 45 degrees. I should probably cut that in half a little nicer. Same with the other one, but honestly it doesn't matter. We're just using this as a tool to figure out what our actual angles are. And again, I like to label this as pi, but it's 4, so I'm going to go 4 pi over 4 and label this as 2 pi, and that's going to be 8 pi over 4. So I did 4s because my reference angle is 4. So if I'm actually going to measure this angle, I'm saying, well, this is 4 pi over 4, but I'm a pi over 4 short. So my answer must have been 3 pi over 4. Not quite 4 pi, just 1 short. And if I was to measure this angle, it's not quite 8 pi over 4, it's 1 short, so 7 pi over 4. So those are my two angles. Now it's worth noting in this, I don't know how much it comes out, tan, so make a little note here, tan of x, as a reminder, is sine of x over cos of x, and cos of x is on the denominator. So cos of x, this whole denominator, as a restriction, you're never allowed to divide by 0. So cos of x is not allowed to be 0. So if you look up here, and cosine is on the left, when does cosine 0? 0 right here, at pi over 2, and right here, at 3 pi over 2. So technically, x is not allowed to be pi over 2 and 3 pi over 2. So just to make a note of that, to make sure that doesn't conflict. Now, none of these answers are those, so we're okay. But whenever you see a tan, that means that x is technically not allowed to be pi over 2 and 3 pi over 2. It'll always be like that because tan of x is always sine over cos, and cos is always on the bottom. So cos of x can never equal 0, and the only times it's 0 is when it's pi over 2 or 3 pi over 2. So these will always be the restrictions for tan of x. So we just need to make sure, we don't have to ever do that again. We can just look at this and make sure our answers don't conflict. Now, we're going to keep going here. So divide this by -2, divide this by -2. We've actually done this question before. Cos squared of x, except for I think this was a 2 and a 4, is equal to 1 over 2. And then we can square root to cancel that, and square root that. So cos of x is equal to the square root of 1, which is just 1, and the square root of 2, which is, well, square root of 2. And of course, you have to add the plus or minus because you're square rooting to cancel out a square. Now, this is very useless to us. It's not helpful at all. So it's incredibly useless, I should say, because none of my answers are 1 over root 2. I have 1 over 2, but I don't have any 1 over root 2s. So if you actually rationalize this, and you say, well, I don't want the square root on the bottom, then cos of x is equal to plus or minus 1 times root 2 is root 2, and root 2 times root 2 is root 4, and the square root of 4 is just 2. So root 2 over 2. Now that is an answer. So I couldn't, 1 over root 2 is not a possibility, but if I rationalize it, I find out that it actually is. So what angle am I referencing? So when is cos equal root 2 over 2? So cosine's on the left, right here, and that is pi over 4. So I'm referencing pi over 4. Now usually when I go through this, I say, well, when is cosine positive or when is cosine negative? But I'm actually looking at all of them because I'm looking for the positives and the negatives, which is why we have done an example like this. So all of my angles are here. All of those. And all of these are referenced at pi over 4. Oops, there we go. And so, it's good to label these. So this is going to be my pi, and I'll do it in 4s. So I'll go 4 pi over 4, and this is 2 pi, which I'll do is 8 pi over 4. So if I'm looking at my angle, it takes there, what does it take to get to here? Well, I've already done it. It's pi over 4. And what about to get to here? Well, 4 pi over 4 would be getting down to here, but it's pi over 4 less. It's less by 1, so it's 3 pi over 4. So it's not quite 4 pi over 4, it's 3 pi over 4. And then what about that one? Well, it's past 4 pi over 4, so it is 5 pi over 4. It's past it plus another pi over 4. And the last one here is what about this one? So I'm almost at 8 pi over 4, but I'm a pi over 4 less shy. So I'm at 7 pi over 4. So those are my 4 answers. And you can go back and look at the question in the other unit, and it's exactly the same as this. So I'll zoom out. These are in the notes, but I know this restriction. I don't know if the restriction is in the notes. But the other two, but these 2 answers are. So that'll be it for the end of this video, and the next video will start the new stuff that's really relevant to everything we've been doing so far.